Good morning, everybody. Welcome to my channel. Today, we are going to learn about entity annotation from JPA API. JPA, nothing but Java Persistence API. This is a framework or technology we use to deal with the database. By using JPA framework or technology jar, we will be able to connect to the database, get the data from the database, store the data into database, and we can do all other operations. CRUD, create, read, update, delete. It's a lightweight. This entity represent a table in the database. When you put that entity on the top of the class, can be represented a that table in the database. So that entity is available from Jakarta.persistence package. Before that, we should know a little bit about ORM technology or framework. ORM, it will be a interface between database as well as our Java project or Java code. So previously we used to write complete Java plain code to connect with the database, transaction management, rollback, additional functionality. But with the ORM technology, we can handle the database connections, database operations much better. Hybrid is the implementation of ORM technology. In this example, if you look at database is there in the right side, left side is a Java class. Invoice is a class. It's deal with a invoice table in the database. Because invoice is an entity, edited entity is available on the top of the class. Means this invoice will be represented as a database table, one of the table in Java class. So this invoice class, we can have some operations to connect with the invoice table and do some operations. All these fields in instance variables you see in the Java class will be represented in the columns in the invoice table. So if you look at in between ORM hibernate I have written. So which means the ORM framework hibernate will takes care of bridging the gap between these two entities, left side Java, right side database. So hibernate will take care of mostly the operations. We need to call hibernate methods internally. Let's look at ORM stack. When we develop Java based application by using Spring Data JPA, basically we connect with the database and do the operations. But internally, Spring Data JPA will use Hibernate or Apache Comps, different ORM implementations. Those different ORM implementations that we can change by using changing the status, changing the jars. So this ORM implementation that we can easily add, modify by using Spring Data JPA. So it's like a plug and play. So that is the advantage with Spring Data JPA. We don't use Spring Data JPA. We need to configure the jars. We need to configure different packages, application data properties for the different databases. With the Spring Data JPA, just add the status. It will automatically configure for any ORM implementations. We can switch different ORM implementations easily with Spring Data JPA. Internally, they connect with the JPA interfaces and deal with the JDBC and databases. The advantage of ORM is that we do not write SQL statements for save, insert, everything. Everything is like object based. We create an object employee class and save the object by using Spring Data JPA. So working with objects will be very easy. And also dynamically we can change databases by simply changing the configuration file and status. And by using this ORM framework, internally they have their own caching, versioning, timestamp. Those features will be available with ORM. We can use through Spring Data JPA, and we can dynamically create those tables by using ORM framework through Spring Data JPA. And we can generate primary key values, foreign key values, additional stuff. So these are all the usages of ORM framework. We are going to use ORM on the top on the with Spring Data JPA in our Java based applications. Again, if you look at this table, this image, right side is the employee table, and I can say employee is an entity name, ID is a primary key column, rest all not a primary key columns, means normal fields. In the entity, we will be using few more annotations. These are all field level annotations. Entity is a class level and annotation, and remaining are field level annotation. ID, column, generated value are field level annotations, as well as remaining one to many, many to one, etc., are also field level annotations. But ID, column, generated value we will be using for normally for each column, but one to many, many to one, many to many, we will be using these columns for joining purpose only. If you know joining, you will be able to use these terms much better. Let's create a sample Spring application. I have written com.example as a group. I will be using Spring Boot 3.4.0 latest. It should be a Maven project, and I will be using JPA. So let's use MySQL. So click on generate to generate the core project. The project has been created and downloaded. So this is the project I have imported. So let's create an entity. Car. How do I make this class as entity? Put entity from JavaX persistence package. So I will be writing few instance variables or columns for the table. I would say private ID, okay, private name, private color. So what is saying persistence entity car should have a primary key. Yes. So let's make this ID as a primary key. So I say ID. Yeah. So this is what. So this car will be an object. If you look at this is the database icon. So this is how we develop entities. I'm going to create some more videos for more details about ID, column, and other stuff for this entity related topic. So mostly this will be the theory. So we are going to develop more applications, more detailed level entities in next classes. So let's run this application. The application is running at 8083. So say, yeah, access this H2 database, connect. See, car has been created. 1, 2, 3, 4. How many columns? I think 1, 2, 3 columns. 3 columns. ID. ID. So this is how we can create entities.